Okay, so our function introduction, so function notation. Yesterday we discussed domain and range of functions, what makes a function, the input values versus output. There can only be one y to every x value. But now we're going to discuss how to write it in function notation. So once we know it's a function, it can be written into function notation. You can think about a function can be thought of it as a machine that assigns exactly one output. Remember, output is our y values to every input. So every one input. And again, input is your x value. So for every x value, there's only one y value. Every input, there's only one output. So f of x is the name of the function. So just like my name is Ms. Sigmund, f of x is the name. It is also the same as y. So exactly the same thing as y. So I am a girl, my name is Ms. Sigmund. So both of those things are two ways to identify me. So f of x is your function notation, but is the same as y equals 3x plus 4. This just notates which one you're talking to or which one you're talking about. The x is the number you're going to plug in. So the number you will plug in. And I say in because, again, this is your input. So what you're going to put in to get out a y value, your output. So again, all your x is input both here and over here. It's inside the parentheses. And then your y, or f of x, is going to be the output once you solve your function or solve the equation. So f of x, this f of x notation is called function notation. And then the 3x plus 4 is the actual function that we're going to use, that they're notating. Find and illustrate f of 2. So that's f of 2. So we're going to take our function. So it's y equals 3x plus 4. And f of 2, we got rid of the x and we put a 2 there. So we're going to put in a 2, which is going to be 3 times 2 plus 4, which is 6 plus 4, which would be 10. Because we did 3 times 2 plus 4 equals y. And that's 6 plus 4 equals y. So 10 equals y. What that is saying is what is y when x is 2. So f of 2 is saying what is y when x is 2. And so it could be y equals 10. You could also write it f of 2 equals 10 because when x is 2, y is equal to 10 because f of x is the same thing as saying y. So these are the same notations, just different letters. And then as a coordinate, when x is 2, y is 10. So then we want to do f of negative 1. So we're going to plug in f of negative 1. Our function is 3x plus 4. So 3 times a negative 1 plus 4 is our function. And y can go on either side. It's fine. If you like it better on the other side, you can. Negative 3 plus 4. If I owe you 3 and I pay you 4, I end up with a positive 1. So the output is a positive 1. So y equals positive 1. When f of x, f of negative 1 is equal to 1. So when x is negative 1, y is going to be 1. When x is negative 1, y is a positive 1. So as a coordinate, negative 1, 1. Because x is negative 1 and the output would be positive 1. Now you're going to use this to, like I said, to name functions. So f of x, we'll call this one Frank. So Frank function, because it says f of x. And then G, Gertrude is my favorite G name. Gertrude. So we have Frank and Gertrude, otherwise known as f of x and g of x. So that's why the f and g are there, is to differentiate between the two functions when there's multiple things that need to be done. So if we were to put x squared plus 3, we got one function machine, and then x plus 1, we have a second function machine. When it says f of 3, this is when Frank of 3. So when x is 3, in Frank function, what is y? Is what it's saying. So when x is 3, in the Frank function, what is y? So I'm going to go 3 squared plus 3, because it was x squared plus 3. 3 squared is going to give me 9. 9 plus 3 equals 12. And that's 12. So y is 12 when x is 3 in f of x. So it's going to be y equals 12. As a coordinate, it'd be 3, 12. And then otherwise, you could write it in function notation. So f of 3 equals 12. All of those notations are saying the exact same thing. It's just a different, whether you write cursive or a different font. So think about it that way. So then we have g of 3. So that's Gertrude. So 3 plus 1, because Gertrude is x plus 1. That machine is x plus 1 down here. 3 plus 1 is 4. So that means y equals 4 when x is 3 in the Gertrude function, or g of x function. As a coordinate, that's 3, 4. Then in function notation, it's g of 3 equals 4. And if you put an f of 3 equals 4 there like I about did, that is absolutely incorrect. You have to make sure you stay and pay attention. So slow down and read carefully. So f of negative 2, that means I'm going to use the Frank function. I challenge you to pause and try it by yourself. So negative 2 squared. Make sure in your calculator, if you were doing this in your calculator, I actually would probably say just don't, but make sure you have parentheses. Because your calculator, if you do not put parentheses, will call this a negative 4, but we know that a negative times a negative is a positive 4. So 4 plus 3 is 7. So y equals 7. So when x is a negative 2, y equals 7 in the Frank function. All right, the next one, again, pause it, try it. Mess up now. You won't mess up later if you mess up now, because then we'll figure out where we're messing up. So we pulled the x out and put a 0 here, because remember, this is g of x. So for g of x, I have 0 plus 1, which means 1. So y equals 1. 0, 1. So when x is 0, y will be 1. And in function notation, again, that'd be 0, x of, oh my goodness, g of 0, sorry, equals a positive 1. They can also take that function notation, and we can do the sum of two answers. So f of positive 2, so we're going to do our Frank function with positive 2. That's positive 2 squared plus 3. We're going to take that, add it to g of 1. So we're going to use Gertrude's function. 1 plus 1. So we used both machines, both function machines. We plugged in a 2 in the first one and a 1 in the second one, because it's 2 for Frank, 1 for Gertrude. So that gives you 7 and 2. So the answer would be 9. So for this two functions, when f of x is 2, when the x value is 2, and then Gertrude is 1, if we add them together, we end up with 9. There's no different way to write that one, because you're actually doing a sum of the two. And then g of negative 1. So we're going to grab Gertrude. So negative 1 plus 1. Add it to f of 1. So we're going to grab Frank. Plug in our 1 and our negative 1. So negative 1 plus 1 is 0. Plus 1 squared is 1 plus 3 is 4. So 4 when we have them added together. Now, when they are notated this way, you are going to work from the inside out. So ignore Frank out here. So we need Gertrude of 2. So Gertrude 2. So 2 plus 1 equals 3. That's using that 2 plus 1 function machine for Gertrude, because that's our g. So we have a 3. So then that 3, g of 2 is 3. So this whole thing, you can ignore it, is 3. And so we're solving for f of 3 now. So we're going to use our Frank function. It's going to be 3 squared plus 3. And that's 9 plus 3, which gives me 12. So when I multiply the solution to g of 2 and then plug it in, so it's a composition of functions. So we're putting them together. But again, so when it's on the inside, you do the inside first. So f of 0, then we use Frank, 0 squared plus 3. And 0 squared is 0, so I end up with 3 again. So f of 0 is done. We've done that work. So now it's g of 3 again. And g of 3, we just solved it. No, we didn't. I'm sorry. We did f of 3. G of 3, we're going to put 3 back up in Gertrude. So 3 plus 1 gives me 4. So the answer to this entire problem, so g f of 0 is 4. And then the one prior, so f g of 2 was 12. Now when you have a variable, Again, this means I just took x out and I put a y in its place. So Frank's function, remember, was x squared plus 3. And in this case, I took an x out of here, and so I'm just plugging in a y in the place of x, just like they did in the notation. Then the last one, so Gertrude of w. So I have Gertrude, which is x plus 1. All you're going to do there is substitute in a w. All right, guys, hopefully that started making sense. You got a second video coming. Wait for it.